Chapter 7 test review. I'm going to start off with some graphs. These are going to be exponential growth or decay graphs. One thing you should know is when this number is bigger than 1, it's going to be growth. And so typically a growth is going to go like this, unless there's a flip. Over here, when it's this fraction, 1/3, anything between 0 and 1, basically, it's going to be decay. And so it should look like that. So you kind of know what it does before we start. Now, this number right here is going to be an asymptote. It's going to be a horizontal line. So I already know, at -1, there's going to be this asymptote, and I want you to draw it in. So find the asymptote. That's the boundary, like right there. That's the bottom limit of your graph. After that, you're just going to have to plug some stuff in, and sometimes numbers work better than others. For example, if you look at this exponent, x minus 2, a lot of the times the easiest thing you can do is plug in the number that would make that exponent equal 0. So I think 2 is going to be a very good number to plug in because 2 minus 2 is 0. If you plug that in, 3 times 2 to the 0 minus 1. Well, 2 to the 0 is 1. So you have 3 times 1 is 3, minus 1 is 2. I know this graph goes through the point 2, 2. Right there. Okay, you can plug other stuff in. If you plug in 0, a lot of the time 0 is an easy number to plug in, but I don't know that that's going to be the easiest thing in the world in this case. If I plug in 0, 0 minus 2 is -2, and that's going to turn it into a fraction. 2 to the -2nd, you've got to flip it and square it. That's going to be 1/4. It's 1/2 squared, it's 1/4. So I have 3 times 1/4 minus 1. That's 3/4 minus 1. That's -1/4. 0, comma, -1/4 is right there. So that, that's going to look like what I thought it was going to look like. It's going to look like this, right? So you can do more points if you need to. Maybe we plug in 3. 3 might be an easy one to do. 3 times 2 to the 3 minus 2. If I plug in 3, that's 1. That's going to be 3 times 2. That's 6 minus 1 is 5. 3 comma 5. It's right here. That's probably good enough. I would start it as flat to the asymptote and then curve it up and hit those points. There is your exponential growth graph. So then for decay, we do pretty much the same thing. I would start with the asymptote. That +1 is going to be an asymptote. So where are we at here? +1. Everything's going to be kind of work off of that. So in this case, again, I think 2 is going to be the best number to plug in because that's going to zero out the exponent. 2 times 1/3 to the 0 power plus 1. The reason that's easy is because 1/3 of the 0 is 1. 2 times 1 is 2, plus 1 is 3. I've got the point 2 comma 3. 2, 3 is right there. So then if you plug in like 0 or something, 2 times 1/3, plug in 0, 0 minus 2 is -2 plus 1. So again, it helps if you can do negative exponents in your head. Negative exponent is just going to flip it, and then you're going to square it. So if I flip that, it's going to turn into 3 squared, which is 9. 2 times 9 plus 1, that's 18 plus 1 is 19. 0, comma 19 is way up there. And so we already kind of know what this looks like, right? We already know it's a decay. So it's definitely going to look like that. And our graph does look like that. If you wanted to try another point, maybe try something like 4. If I plug in 4, 2 times 1/3 to the 4 minus 2 is 2 plus 1. 1/3 squared is 1/9 times 2 is 2/9 plus 1. That's 1 and 2/9. Or I guess if you use a calculator, that's about 1.2 repeating, I think. 1.2. So 4 comma 1.2 is going to be down in there. And again, I think our graph is looking pretty good. Keep it flat to the asymptote and then curve it up through those points. That's decent. Okay. It's been a while since we talked about those, so maybe you've forgotten. I think the rest of this stuff is going to come back fairly quickly. Solve each equation. The best thing you can do on this one is get the two numbers to match, a 36 and a 216. And maybe you don't want to do that, but I think if you change this 36 into 6 squared and this 216 into 6 to the third, that's the easiest way to do this problem. The problem is that doesn't always work. So if I was going to do this, I've got number parentheses number, so that means multiply them. 6 to the 4b plus 2 equals 6 to the third. Once you've got those bases to match, they cancel each other out. And so we can just look at the exponents. We've got 4b plus 2 equals 3. Subtract 2, that says 4b equals 1, and divide by 4, b equals 1/4. Now there is another way of doing that problem I think you're going to like better, but we'll get to that later, I think. Rewrite each equation in logarithmic form. In order to do this, you have to remember that the logarithm is equal to the exponent. Okay, log equals exponent. Log equals exponent. So right here is the exponent. That's what the log is going to equal. This thing is the base. That's important as well, because we're going to say something like log base 6 equals the exponent. And so if I change that into logarithmic form, it's going to say log base 6 of 36 equals 2. Not much to that, but that's what it is when you convert, okay? So the next one, we are going to rewrite in exponential. So it's going to go the other way. Again, what's happening is you've got to remember that a log equals an exponent. So a log is an exponent. So that means this thing right here is the exponent. We're rewriting this in exponential form. That is the exponent. That is the base. So we've got a base 32 with an exponent 1/5 equal to that other number. That's exponential form. Evaluate each expression. Now, I showed you two ways to do this. One way is to use a calculator. So we can do the change of base formula by doing log 9 over log 3. Change of base formula is 2. But without a calculator, I can just say, I've got a base 3. I know that that log equals an exponent. And so the first way we learned how to do this was we set it up by using our conversion, and then we change that 9 into 3 squared. X equals 2. But I think the second way you liked better. Once we got into the calculator stuff, we used that change of base formula. That's probably going to be easier. And that's what I was talking about earlier when I said there's another way of doing problem number 3. If you remember the change of base formula, I think that's going to help a lot. All right, moving on. Solve each equation. These logs are going to cancel each other out. So really all we have to do are the arguments. I always like to take out the smaller variable term. So I'm going to add in to both sides. Give me 2n plus 9 equals -1. Let's subtract 9. That gives me 2n equals negative 10. Divide by 2, n equals negative 5. Now, on number 8, it's different. It's harder because the logs don't cancel out. But remember how we ISO a variable. We're going to isolate a variable. We need to get rid of that log base 4, and we do that with a base 4. We're going to do a base 4 on both sides. That cancels our log. X minus 1 equals 4 to the negative first. Remember, a negative exponent is going to flip. Okay, negative exponent flips. So x minus 1 equals 1/4. I'm going to add 1. X equals 1 and 1/4. Expand. Expand. Remember that times right there is going to be a plus, and that exponent 2 is going to come to the front, and that exponent 6 is going to come to the front. Expand means to make bigger. I'm going to have log base 2. Whoops, I'm going to have a 2 in the front. Log base 2 of x plus a 6 in the front of log base 2 of y. Don't forget the little base 2. If it's a log base 2, you got to say it's a log base 2. Now on the next one, we remember that division goes with subtraction. And it's the same thing. Exponent 5 to the front, exponent 6 to the front. You're going to have 5 log base 9 of x minus 6 log base 9 of y. I think it makes a lot more sense when we go the other way to condensing. Condensing is good and useful for solving, and we'll definitely have to use that in some of the later problems. So times will change to plus. This 5 will go around behind, and this 4 will go around behind. So I can condense into a single log base 4 of x to the 5th times y to the 4th. Likewise, here you're going to have 2 multiplications and an exponent that goes behind this z. I can change it into a single logarithm. It's going to be x times y times z to the 4th. We need those properties to solve number 13, solve this equation. If you're going to solve it, do not just delete the logs and ignore them. If you've got 2 logs, you're going to have to put them together using those properties. I know that log plus log is going to change to times, so that's going to be log base 8 of negative 4x times 7 equals 3. Now, do not just delete the log base 8. The way we get rid of this log base 8 is by taking a base 8 on both sides. Yuck. That's going to be a really big number. 8 to the log base 8 cancels out. We're going to have negative 28x right here, because I multiplied, equals whatever 8 to the third is. 8 to the third is 5/12. And so now to solve, we would just divide by negative 28. And I'll use a calculator. Okay, let's round off to 3 decimals, 286. Negative 18.286 or so. Next one. Again, we've got to combine the logs. So you don't want log minus log. You're going to change that to division. It's going to be log base 3 of x plus 1 divided by 2 equals log base 3 of 12. Now you can do a base 3 on both sides, but in this case, it's going to cancel both logs. So that's kind of nice. I would see x plus 1 over 2 equals 12, and I just do a solve. So times 2 times 2, x plus 1 equals 24. Subtract the 1, x equals 23. (15) Log base 5 of 66. Remember, a log is an exponent. And so we're trying to find the exponent that makes 66. That's what we're doing when we do a logarithm. We're finding that exponent, okay? But here, in order to do this, we can do the change of base formula. Log 66 over log 5. This is an easy problem if you remember what to do, but that's why you need to study. 2.60, it says round to the nearest thousandth, so that's 3 decimal place. 2.603. And so remember what you're doing. You're finding the exponent that makes 66. So if I do 5 to the answer, that's 66. Only reason it's off is because of the rounding. Okay. So then 16, solve. We're trying to ISO, so let's add 7, and that says 5 to the v equals 56. I want the exponent that makes 56. So how do I find the exponent that makes 56? I'm going to do a logarithm. If I try to ISO, I'm going to do a log base 5 on both sides. Log base 5 cancels out your base 5. V equals whatever log base 5 of 56 is. So again, I can use my change of base formula, log 56 over log 5. 2.501. It says round to the 10,000th, so 5011. 2.5011. '17, natural log. Natural log is a base e, and e is about 2.7 or so. But this one, number 17, just type it in. Natural log 60. 4.094. 4.094. Again, that's the exponent that makes 60. So you've got a base e to the 4.09 blah, 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 gives you 60. Next one. Those natural logs cancel each other out. So we've got 4r plus 7 equals 3r plus 8. Subtract over the 3r. Gives me r plus 7 equals 8. R's got to equal 1. Subtract 7, you're going to get 1. 19. Get rid of a natural log with a base e. That's something you're going to have to remember. Cancel out a natural log with a base e. So x plus 2 equals e to the 4th. E to the 4th. 54.598 or so. X plus 2 is about 54.598. We're going to subtract 2. X is 52.598. Whoops, it says round to the 10,000th. That's 4 decimals, so 5982. Expand each logarithm. Well, we already did this, right? 4 goes to the front. This is minus. 3 goes to the front. So natural log, whoops, 4 natural log x minus 3 natural log y. It's the same thing. It's just a different base. Now it's a base e. This is going to change to plus. This is going to change to plus. The 4 is going to go to the front. So I'm going to have natural log of 12 plus natural log of 11 plus 4 natural log of 5. Condense. This is going to be times. This is going to be times. This 4 goes to the back. Natural log of u times v times w to the 4th. This is going to be division. This is going to go to the back. This is going to go to the back. Natural log x to the 3rd over y to the 2nd. Solving. I've already done this. Got to condense first. So that's going to be times. I'll have natural log of 3 times 3x. Let's go ahead and call that 9x equals natural log of 25. Base e cancels out your natural logs. Oops. So 9x equals 25. Solve this. ISO x, we're going to divide by 9. X equals whatever 25 over 9 is. Last one, need to condense. So this plus becomes times. Natural log of 8x plus 48, when I multiply that, equals 2. We're going to need to do a base e to cancel out that natural log. I get 8x plus 48 is whatever e squared is. E squared, 7.3891. 7.3891. 7.3891. Subtract 48. That's negative 40.6109. 8x equals negative 40.6, I forget, 6109. And then divide by 8. Negative 5.0764. Done.